This is how the James Webb Space Telescope explores alien worlds. Can we end up locating aliens? Do we have enough faith in our spacecraft and technology that we can go on and explore worlds that are alien to us? We are focusing on our technology because that is the priority that needs to be addressed. Whether aliens exist or not is a topic for another day, because if we do not have that spacecraft, then the question of aliens existing or not will be pointless. But now we might have something on our hands that might help us explore extraterrestrial life worlds. But it's far from the spacecraft. The James Webb Space Telescope, JWST, will help us explore alien worlds. This telescope will be the largest in the history of NASA, and it is the result of a collaboration between NASA, the European Space Agency, and the Canadian Space Agency. NASA managed to bring together around 300 universities, organizations, and companies across 29 states in the USA. This telescope is going to probe the entire cosmos, as well as assist us in locating extraterrestrial worlds. This telescope is slated to replace Hubble telescope, but during the beginning of the JWST's lifetime, it will work together with the Hubble telescope. The telescope is gigantic. It is the size of a tennis court, and it is made up of 18 small hexagonal mirrors which are made up of beryllium-coated gold that has been optimized for reflecting infrared light from the end of the universe. You then also have the primary mirror backplane assembly and the deployable tower structure, which lifts the telescope off the aircraft. 3 arms are present at the top that come together into a ring where the secondary mirror shall be residing. Instruments and operation. Looking for the first glimpse of a star? The James Webb Space Telescope has its instruments powered up. The star made the central observation point is the HD 84406, which is located 241 light-years from the Earth. The images of the star will be taken by the Webb Near-Infrared Camera NIR-CAM, which will cool down first to its operational temperature, which is -244 Fahrenheit. At the beginning of the picture snapping process, there will be 18 dedicated images, but at the end there will be only a single focused image that will be left. The NIR-CAM will be focused on stars right now, whereas Webb's optics experts move the mirror segments in nanometer scale steps to create a perfectly smooth surface. The first clear images expected to be released to the public taken from the JWST could be as early as late June or early July. The 3 remaining instruments involved in the imaging will be Mid-Infrared Instrument, MIRI, which is already partially turned on during the telescope's month-long cruise towards its destination. As for the other 2 instruments, which are the Near-Infrared Spectrograph, NIR-SPEC, and the Fine Guidance Sensor, Near-Infrared Imager, and Slitless Spectrograph, FGS Near-IS, the control teams have turned off the heaters that kept them warm during the cruise phase. These heaters allowed these instruments to slowly release the trapped air inside of them to prevent condensation of water along with the buildup of ice. As the NIRCam and MIRI have already begun to produce incredible images of stars and galaxies, spectrographs will provide further detailed info on the chemical composition of distant objects. All the working temperatures of these instruments are kept low. This is necessary because their temperatures play a crucial role in giving the JWST its scientific capabilities more or less. They're designed to image the oldest stars and galaxies in the world that came to life in the universe hundreds of millions of years after the Big Bang, due to the expansion of the universe. Light that was emitted by these galaxies is visible only in the infrared wavelengths. Since infrared heat is heat, the dim signals wouldn't be noticeable if the telescope radiated warmth. Stunning imagery will be a norm from the JWST, and when we get to receive the breathtaking images of space, that will be the time we can go on and appreciate the JWST for its work. We hope we get to see lots of it because the telescope should be good in its functionality and appearance. The stars this telescope will be focusing on will be for good photography sessions. JWST will have a good time as it captures the images of stars. As we get pictures of the new constellations in our skies, the thing that needs attention is increasing its focus. With 18 images being received at the start and 1 focused image at the end, there needs to be a way to focus on these celestial bodies quicker. There shouldn't be a need for 18 images to show up at first and then a single clear image that comes up. With fewer images of a single body, there will be more time to focus on other celestial bodies. Exploring alien worlds. In terms of exploring alien worlds, the JWST during its first operation cycle is going to set its sights on the TRAPPIST-1 system, a decorated collection of 7 rocky exoplanets which are 41 light-years away from the Earth. TRAPPIST-1 is the perfect laboratory for studying habitability, with 7 rocky planets distributed across the entire habitable zone, or the area around a star where it is not too hot and not too cold for liquid water to exist on the surface of surrounding planets. The JWST will characterize the atmospheres of these planets and help scientists learn more about planetary formation and habitability. We're stressing natural laboratories because some stars are too hot to be studied because of their proximity to stars. Some planets in the system are present just at the proper distance from their star to be habitable, and astronomers have stressed that the TRAPPIST-1 system might also give them a route to discovering other alien worlds. Some of the planets in the TRAPPIST-1 system are just at the proper distance from their star, making them habitable. When one of the planets in the system is too cold to be habitable, if we predict the colder planet, we can see that it is cold and frozen, making it almost impossible to study. So by studying the planets in the system and comparing them and their features, we can learn a thing or two about how planets vary based on their habitats. This is also dependent on the distance these planets have from their stars. The planets that are going to be closer to the star will have higher temperatures, whereas planets that will be further away will have lower temperatures. Different processes will also be seen that will enable or destroy habitats present at the distance from their stars. And the most important thing to note is that all these planets orbit the same star, which means that they are formed together and they all experience the same process from their star throughout their lifetime. We also want to search for signs of biosignatures in the atmosphere of potentially habitable TRAPPIST-1 planets. If we end up finding exciting things, then that will give us a lot of good details. This is because low-mass stars like TRAPPIST-1 are different from our massive star, the Sun. These stars from TRAPPIST-1 are stars having a low mass because they're active. They produce a lot of high-energy flares, which produce a lot of high radiation. If we compare activity on the Earth to planets of the TRAPPIST-1, then there are differences seen because of the activity of both stars working on their respective planets. It's interesting to compare these planets with the Earth because although their activities might not be similar, several differences can help us understand extraterrestrial life better. The JWST will help in studying these planets and their stars better. With the imagery functions defined above, this telescope has enormous potential, which can help us unlock the existence of alien worlds. This brings us back to the first question. Can we end up locating aliens with a JWST at our disposal? We certainly have a chance. This is because this tool will give us access to worlds that we've never imagined of. The JWST will open up a new world if we take its functionality to the next level. Whether we can find aliens or not is still a huge mystery because this telescope has a long way to go right now. We hope that this telescope is used the right way because it would be a crime not to use this technological marvel the right way. We can't wait for the first pictures of this telescope from the outer atmosphere. That's all we had for today's video. Make sure to give a thumbs up to this video and subscribe to the channel to ensure you don't miss any other new videos. You can also click on the bell icon to get updates from us.